Hi, I'm Jan Ozer. I'm here today speaking with Ville-Veikko Mattila, head of Multimedia Technologies at Nokia, discussing a recent announcement that Nokia made with Ericsson and Fraunhofer regarding 6G-Era video coding standardization. Thanks for joining me, Ville-Veikko.
Yeah, thanks, Jan, for having me, and it's a great opportunity to share a bit about our work on video coding standardization.
Okay, so give me some background on this. We all know that H.267 is coming. Is this a proposal that relates to H.267, something else, or something else altogether? What is this? What can you tell us about it?
Yeah, so this press release came out on Monday this week, and it is exactly about this joint work. By Nokia, Ericsson, and Fraunhofer and the Hertz Institute. And so it's about our response to this call for evidence when it comes to video compression standardization, that we could develop a new codec standard, something what then is beyond VVC when it comes to, for example, its compression performance.
Can you give us any background on this? There were some things about European technologies and some things about participation from Europe as a whole. Why is this important to this standard? Why is it important to people who may use the standard down the road?
Yeah, that we have a long background at Nokia developing video codec standards, so kind of longer than 3 decades. And if you think about moving from standard to the next standard in video coding, so the typical requirement is that you should achieve something like 50% video compression gain while still maintaining the same picture quality. So basically kind of doubling the compression efficiency. And as we know, nowadays, something like 75–80% of all the traffic in communication networks is video. So therefore, such achievement that, okay, suddenly you can double the compression efficiency, of course, it can have a very huge kind of global impact on traffic and communication traffic. So, and then therefore, we are again then approaching and exploring kind of new technologies and a new standard for video coding. And so we have this name H.267, even though that officially it's not yet decided that, okay, what really the name for the new standard is all about. But we are in the exploration phase currently. So we developed the current standard, versatile video codec H.266, that we completed in 2020. And since that, we've been then exploring the next generation of video coding. And we do know that the amount of IP traffic is increasing quite quickly. So it's something like 28% every year. So therefore, we also do need the better compression technologies to provide these various kind of experiences like video on demand or support for social media videos, or even for video conferencing, for example, what we have now here.
Okay. Do video codecs need to be kind of network aware? Is the network knowledge that you bring to the table in Ericsson helpful when it comes to video codec development, or is that just kind of extraneous?
Well, there are actually, of course, multiple standards that you basically then need at the end to really implement a service that, okay, whether it is a video on demand, where perhaps the latencies are measured in seconds, or whether it is then for video communication, where then latencies are much shorter. So of course, video codec as such, so they produce a compressed bit stream, and in that way, they are kind of agnostic when it comes to then to the kind of network technologies themselves. But of course, for example, these codecs like VVC, they are widely applied to, for example, mobile communication, but also then for video on demand and social media services.
Okay. So your announcement spoke about a proof of concept. What is that? Is that a working codec implementation or an early research model that was submitted for evidence?
Yeah, the proof of concept is a fully functional kind of codec implementation. It's not just a research model, and it is developed as a part of this joint call for evidence on video compression beyond VDC, so beyond the current latest standard. And it demonstrates that higher compression efficiency is possible, and it's possible also with lower encoder complexity and with improved inertia efficiency. And this was jointly created by us at Nokia, then Ericsson and Fraunhofer. And we just had a meeting earlier in this month where we evaluated, and here we meaning the JVET, so this joint video expert team of ISO IEC and ITUT. So this team then also evaluated all the responses, and our responses was kind of really kind of evaluated to provide great performance and very much this kind of balanced complexity compression performance. So keeping the complexity low, but still being able to provide very nice compression gain.
Can you know, what were the compression gains that you quantified? Can you share that?
Well, we, of course, in standardization, so we, of course, have the previous standard as a kind of reference. And so we compared against VTN, which is the kind of test model for VVC. And then against that, we can achieve almost kind of 30% compression gain as a part of this response. And also achieving that with encoder complexities that are not higher than what we have with VTN.
Okay. So it seems like the bottleneck for implementation on most of these codecs recently is, and certainly VVC has been the playback side. So what are the playback resources that you're targeting for this new this new model that you're proposing?
Yeah, I think that if you think about the playback resources, okay, what kind of resources it then would need. So I think it's quite early to specify exact requirements. I mean, really, because we are still in the exploration phase, and the actual collaboration phase regarding then towards 267, that then should only start in 27, early 27. But of course, the standard, we want that to be designed for a wide range of devices and architectures. And also we have a great examples. I mean, if you think about VVC, for example, Fraunhofer has an open source software encoder and decoder available. And for example, if you think about the decoder, that can run on software on kind of general purpose CPUs. So I think it's also good to notice that that we do not necessarily need a kind of hardware implementation for the decoder anymore. But of course, the new standard may also be very unique in the sense that it is the first time when we also integrate neural network technologies as a part of the codec. And therefore, if you think about the decoder and inferencing these technologies as a part of the decoder, that may then require, for example, NPUs going forward. But it's quite early to say anything because we don't yet have the codec in place. So we are still exploring these technologies.
Well, of the model that you proposed, how big a component was AI versus, you know, some of the traditional technologies that you pioneered and, you know, 30 years ago?
Yeah, so the response that was jointly developed by us, Ericsson and Fraunhofer, so we had two different versions. We had one version which is then more about kind of conventional coding, and then in the other response we added neural network-based kind of loop filter as a part of the response. So so these were the kind of two responses we submitted.
Are these alternative responses, or are you expecting, I guess, a hybrid type codec, or how do you see this working down the road?
Yeah, so definitely hybrid codec could make sense. I mean that of course neural network technologies are quite interesting, and they also have shown great performance for a certain test cases, which then are otherwise can be challenging for conventional coding. For example, test cases where you have for example, running water, or for example, grass. So these kind of cases that is quite difficult to kind of do kind of interprediction, for example. And we have learned that that neural network-based technologies can be quite handy to provide kind of texture which may be otherwise missing. So whether the texture is then really authentic is another question, but it definitely can look very good. So these technologies can be quite handy to improve the subjective quality of video.
Okay, so just to kind of make sure that we're saying the same thing here, are you hoping that your technology will be able to decode in software, I guess on mobile and computers?
Yeah, I think it's very interesting kind of exciting kind of opportunity that if you could really run the decoder in software, because basically it then also would mean much faster kind of entry to the market. So you wouldn't need to kind of wait for the hardware implementations before bringing the codec to the market. And especially considering the kind of use cases like video on demand, where the content is, say, encoded once, but then consumed by many, so decoded by many. And so the decoder could, as if it's running in software, could even be a part of the application, so the streaming application.
What happens on smart TVs and similar devices that typically don't have robust CPUs?
Well, of course, I'm sure there will be many alternatives, and definitely also hardware implementations for the encoders and decoders. But then perhaps in some cases, for example, if you are consuming video on your mobile, so you could also run the decoder in software.
Okay. And I think certainly computer and mobile are big enough markets to warrant a separate codec or a separate implementation of a codec if that would accelerate deployment, as you say.
Yeah. So many people are going to use nowadays their mobiles to kind of really watch video. That's very, very common, of course.
One of the things that accelerated HEVC adoption, at least in my opinion, was the fact that it opened up the HDR 4K market. So it seems like codec adoption is generally accelerated when it opens new market for the publishers who use them. What do you see as being possible for this new codec in terms of new markets that could accelerate its adoption?
Yeah, there can be, of course, new markets, new experiences, or then we can also very much enhance the kind of existing kind of experiences. I mean, the codec we should complete the codec in 2030. So there's still time before the codec becomes available, because after 2030, it will then still take perhaps a couple of years before it's integrated into hardware and so on. So that's something like 2032, something like that. So then what all kind of new experiences we may then have for media for at that time. Of course, there's a lot of discussion about immersive video or immersive experiences. We are already familiar with virtual reality, with augmented reality. There's a lot of competition and high investment to develop, for example, augmented reality glasses today. This also then relates to kind of other technologies which are under development, for example, in MBEC, which then relate exactly to immersive video. For example, Gaussian splat coding is a kind of ongoing effort. There's a lot of interest in Gaussian splats because they can provide very high quality 3D video. So basically, you can even then walk into the video in a way. You can walk around the video. And nowadays, of course, still the bandwidth requirements are pretty high. So it can be several hundreds of megabits per second. And then if you think about these kind of immersive video technologies, so typically these are application codecs. So they are implemented on top of these kind of core codecs like VVC and this upcoming H.267. So together they can of course then enable, for example, volumetric video in the future in a scalable way, so that the bandwidth requirements would be low enough to be able for many to consume such video. So immersive experiences, perhaps that's something new that will come up. But of course, then even higher quality streaming, for example, for mobiles, even on this kind of constrained networks, that is important. Cloud gaming, I'm sure there's a lot of interest in that. So you're basically turning every video playback device into a gaming device. That's also quite attractive if that could really happen. And but also, I mean, on the kind of industry side, I mean, there's many applications for video when it comes to industries. So so quality control, industrial surveillance, automation, all of these, and how we could then kind of optimize the video delivery for machines. Perhaps, for example, requiring low latency operation. That's for sure will be important.
I mean, they're developing standards for that, like, you know, VCM and feature coding for machines. Do you see this codec as potentially competing with those as well?
Yes, they are, of course, other standardization tracks also ongoing. For example, in MPEG, exactly that are developing video coding technologies for machines, like video coding for machines and this feature coding for machines. And these are quite different technologies. However, I mean, they may also use existing these core codecs like DVC as the inner codec. So again, these core codecs become the kind of very kind of fundamental part even of these other standards. So they rely on these core codecs, but they develop something, I mean, on top of that. For example, this FCM you mentioned, so this MPEG feature coding for machines. So it's quite different because here we are actually transmitting features. So not really the video as such, but we have feature maps, which then we apply video coding to transmit them to the other side. And in a way, the features then relate to the machine vision tasks and the neural networks, which are particularly designed for those tasks.
Okay. What about the encoding side? You mentioned decode. What's the encoding side look like in terms of complexity? And also machine requirements. I mean, is it GPU based? Is it CPU based? Is it ASIC based? What do you see happening?
Yeah. Now when we are kind of discussing H.267, so it's very early to say anything because we don't really have the standard and technology in place yet. But typically, of course, if you think about encoders, so hardware implementations are needed. We will see then later that, okay, what then really the requirement is for the new codec. But if you can think, for example, use cases like user-created content, of course, encoder matters a lot so that you'll be able to record video and compress it and share it to the social media service. So I'm sure in these cases, so hardware implementations may be very, very much needed.
The you know, you're talking about dates out to, you know, 2030 and 2032 for first implementations. What are the risks of a totally different technology, perhaps AI based, coming in and just, you know, just kind of taking over, just gaining acceptance in the market? I mean, it's such a long timeline, and I guess we didn't think about it, you know, in 2013 when HEVC came out because we didn't have AI around. Now it seems like AI is accelerating everything. What do you see as the risk of an AI codec coming in and just, you know, becoming the accepted standard?
Yeah. So we of course already discussed about hybrid coding, so that we can basically enhance the conventional video coding by new neural network-based kind of technologies, and that can of course be one solution now going forward. That we take the kind of benefits from both sides. If you think about conventional and then neural network-based, and of course, one challenge, for example, if you think about neural network-based coding is that the inference at the decoder side, perhaps the complexity is still very high. And then if you think about kind of pure end-to-end kind of learned codec, so there are many examples out there. So there's a lot of research exploration for these new technologies. And perhaps if you have a kind of walled garden kind of ecosystem, so you can implement if you know your hardware, for example. But there's also what we also have realized when developing these AI-based, neural network-based technologies is that that sometimes when these technologies are implemented on different hardware, so suddenly they may not be kind of fully interoperable anymore, or you may have challenges to exactly reproduce the same results. And so therefore, if you think about the kind of ecosystems that different companies could develop encoders and decoders separately, and they would be running on different hardware. So we are not quite sure yet that how feasible that actually then is in practice. Exactly because if you think about the different hardware, so if even the kind of calculations are implemented in a different way, and also if you think about hybrid methods, so if you are applying neural network-based coding, for example, as an in-loop filter, so the whole system may also easily become unstable if you do not take these issues into account when it comes to running these algorithms on different hardware.
You may have just addressed this, and excuse me if you did, but one of the issues that I've been kind of grappling with myself is just the general applicability, I guess the general intercompatibility of NPUs. Can you comment on that? I mean, if Apple has an NPU and NVIDIA has an NPU, can you develop one codec that plays on both, or is it not going to be that simple?
Well, I think it's a very good question, and it's also something that what we are addressing in standardization. It's something what we are exploring actually, for example, in MPEG as a part of this MPEG AI umbrella of standardization. Exactly these topics and questions regarding the reproducibility, that can you and how you could kind of guarantee that you produce exactly the kind of same results. So it's a very interesting and that kind of domain for new research, and also that, okay, what new methods we would need to develop to guarantee this kind of interoperability between different implementations of encoders and decoders, in case it's kind of, for example, fully NN based.
Okay. So when does a typical publisher, when does Netflix or Paramount need to start thinking about H.267? Walk me through the timeline, the best case timeline for implementation.
Yes, right. Okay, so as I mentioned, so when we kind of completed the VPC standard in 2020, so I mean, since that we've been gradually then exploring the new technologies for H.267, and we had this joint call for evidence, which was evaluated now in October. And then the next phase is then call for proposals. And this is now a call for organizations, companies, universities to submit their codec proposal to JVET. And we will review these proposals in January 27. And then we will see that if there's a winner or winners, and what all kind of well-performing technologies we can pick from the responses and these proposals. And after that, we then start the collaboration phase. And the collaboration phase should last for 3 years. And that then takes us to January 2030. So that is then the approximate kind of time when we complete the standard, the new standard.
Okay. And then I guess best case for, I mean, you're saying software playback may be available then. So at least on some platforms, the standard could be usable at that point. And I guess for silicon, it's the typical 2 to 3 years to get the first samples, and then however long it takes to get a significant penetration from there.
Yeah, at least that is something what has happened before. You're right.
Okay. What's your sense of where VVC is right now?
At the moment, so VVC is by far the best performing codec in the market. So it's called versatile video coding because it provides good performance for many different content types. Of course, high definition, ultra high definition, high dynamic range, standard dynamic range. So it has also capabilities for 360-degree video. So this kind of virtual reality video. It has capabilities for low latency coding, for screen content coding. So it is truly versatile. And as a standard, it provides the best compression performance today.
What about the implementation side? I mean, you talked about software decoding for VVC.
Yeah.
I guess we hear kind of rumors about that in China, but nobody seems to talk about it. Nobody seems to deploy it on platforms where people, like in the United States. So what's your sense of how much VVC is actually out there, being used today as compared to the potential?
Well, it's very much coming to the market. It's also integrated to the broadcasting standards in Europe, in the US or North America. So, for example, I think pretty much all TVs may have the hardware already implemented. So sometimes it's then a question about that the firmware might be missing, or then, for example, the supporting player might be missing. So in a way, you perhaps can then find the application in the store that can already now play back VVC coded content. But currently, I think it's a very attractive codec. So, and typically, once we have a standard in place, so it takes some years to really get to the market. And I think this is gradually now happening.
Okay. Well, thank you for taking the time today. Congratulations on your collaboration with Ericsson and Fraunhofer, and we look forward to seeing more news about this in the future.
Okay, thanks, John, and thanks for having me here. And it was